In this video, we will look at solving linear equations with complex denominators. So what that will typically mean is that we'll have something that looks like a rational equation. A rational equation is an equation that looks like a fraction and often has variables in the denominator. But when we modify it, it will turn into what looks to be more like a traditional linear equation. I'm going to provide two examples of that. I'm going to employ a technique I used in a previous video called clearing fractions. We do have one caveat, or one thing we have to consider is what if we multiply both sides by 0. Let me show you what I mean by that in this example. So we have 3 over x minus 5 equals negative 2 over x plus 7. Our job is to solve for a value for what the value of x might be. Now notice that if x were 5, if we multiply both sides by x minus 5, we would in fact be multiplying by 0. So that's going to be an issue, but I'm still going to consider what the LCD might be between these two fractions. On the left-hand side, we just have a factor of x minus 5, okay? The right-hand side, unfortunately, does not have anything in common. The factor x plus 7 is not a multiple of x minus 5, so it's completely different, and we also have to include that in our LCD. So our LCD is actually both of those factors. So what I'm going to do in this technique to solve is I'm going to multiply both sides by the LCD. On the left-hand side, when I multiply by x minus 5 times x plus 7, what happens is the x minus 5s simplify, and I'm just left with 3 times x plus 7. When we distribute that, we get 3x plus 21. Now, we'll do the same thing on the right-hand side. To keep this balance, we'll multiply by the LCD x minus 5 times x plus 7. Notice this time the x plus 7 simplify. We're left with negative 2 times x, negative 2x. And negative 2 times negative 5 will be a positive 10. Notice now it looks like a traditional linear equation, and so we'll employ the steps there. With variables on both sides, I'll begin by adding 2x to the right side and to the left side, leaving me with 5x plus 21 equals 10. My next step, I'll subtract 21 from both sides, leaving me with 5x equals negative 11. And then one last step, to get x by itself, dividing by 5 on both sides, x will be equivalent to negative 11/5. Now this answer seems to be good because it doesn't cause any issues of dividing by 0. Let's take a look at one other example. I told you I would give you two examples. The second one is a little more complex. Let's solve this equation. Solve 5 over x minus 2 plus 1/3 equals 1 over 5x minus 10. This looks like there's really not a lot in common. Notice that the very first denominator is x minus 2, as opposed to the second one, which is 3, and the third one looks completely different. But if we notice that both terms have a factor of 5, we can consider that this could be factored by factoring the 5 out as 5 times x minus 2. Now notice that it actually does have something in common with that first fraction on the left-hand side, an x minus 2. So our LCD in this case, to make that up, we definitely need a 3 and a 5, 3 times 5 being 15. And then we just need a factor of x minus 2 as well. So the LCD will be 15 times x minus 2. So employing the clearing fractions technique, we're going to multiply both sides of this equation by that. Okay, so on the left-hand side, we'll multiply that by 15 times x minus 2. And we'll do the same thing on the right side. We'll multiply this times 15 times x minus 2. I'm going to actually begin on the right-hand side because it looks a little faster. Notice this x minus 2 and this x minus 2 will simplify. And we're just left with 1 times 15, which is 15 divided by 5. And that will be just a whole number 3. That cleans up really nicely. On the left-hand side, got to be careful with this one. I have some distribution. When I multiply these first two terms together, what will happen is the x minus 2 on the outside right here. I don't know why I put a heart on the screen, but I did. So just ignore that and be like, where did that heart come from? I hit some kind of emoji there. Hope you guys enjoy that on the video. Anyway, this x minus 2 will cancel out with the 1 on the bottom here, and we'll just be left with 15 times 5, that being 75. When I multiply the second fraction, what will happen is the x minus 2 will not cancel, but rather 3 will go into 15 5 times, and I'll have 5 times still that x minus 2. So several steps later, we'll be able to solve this. You would then distribute 5 times x, 5 times negative 2. Combine like terms, 75 minus 10 is 65. Subtract 65 from both sides. leaving me with negative 62. And then lastly, dividing by 5 will give me x as a value of negative 62 fifths. If you wanted to get a decimal value, you could to make that interesting as well. That's how you solve these types of equations. I hope that helps.